Welcome to this essential interview guide crafted for individuals preparing to become a telecommunications line worker. This role demands a unique mix of technical knowledge, physical capability, and safety awareness. In this video, we will walk through the top 10 most relevant and commonly asked interview questions for this position. Each question and answer will help you gain confidence and clarity about what employers are truly looking for. Whether you're a fresh applicant or shifting within the telecom industry, these insights are tailored to support your preparation journey. 1. Can you explain your understanding of a telecommunications line worker's role in network infrastructure? A telecommunications line worker plays a crucial role in establishing, repairing, and maintaining the physical framework that supports voice, data, and video communications. This includes installing and servicing aerial and underground cabling, poles, and other support equipment. Line workers must understand signal flow, line routing, and the connection of devices to ensure consistent network performance. During installation, they climb utility poles, work in confined underground spaces, or navigate tough outdoor conditions. Beyond technical work, the job requires interpreting blueprints, following specifications, and complying with safety regulations. Since networks often cross city or rural terrains, line workers may work at varying heights or in challenging environments. Also, they may collaborate with engineers, technicians, and city planners to ensure alignment with infrastructure plans. Their duties include splicing, grounding, and terminating lines, identifying faults, and repairing damaged systems. Proficiency with tools such as cable lashers, bucket trucks, and signal testers is essential. They also need to adapt to advances like fiber optics and wireless networks. Therefore, a line worker is both a technical specialist and a field operator whose contributions are central to network functionality, performance, and expansion across communities. 2. What safety procedures must a line worker follow when working on poles or underground systems? Safety is the foundation of a telecommunications line worker's daily responsibilities, especially when working on poles, rooftops, or within underground facilities. These environments are inherently dangerous, with risks such as electrical shock, falls, confined space hazards, and environmental exposure. Line workers must adhere to personal protective equipment, PPE protocols, which include hard hats, gloves, safety glasses, fall arrest systems, flame-resistant clothing, and safety boots. Before beginning any job, a site assessment is mandatory to identify potential hazards. If climbing is necessary, the pole must be tested for stability, and certified fall protection equipment must be properly worn and anchored. For underground work, atmospheric testing for toxic gases and adequate ventilation are required before entry. Lockout-tagout, LOTO, procedures must be followed when working near energized lines or equipment to prevent accidental activation. Use of insulated tools and maintaining safe working distances from live circuits are also part of the standard safety regimen. Emergency preparedness, such as CPR training and having a rescue plan in place, is vital. Training, compliance with OSHA or local safety guidelines, and regular toolbox talks reinforce safe behaviors. Safety is not just a practice, it's a mindset and culture that protects both the worker and the surrounding public. 3. Describe the process you would follow to install a new overhead telecommunications line. Installing an overhead telecommunications line is a detailed process that begins with planning and preparation. First, the technician must review maps, blueprints, and job specifications provided by engineers or utility planners. This ensures the correct routing, proper clearance from power lines, and compliance with codes. Next, the job site is surveyed to identify existing poles, anchors, or obstacles. If new poles are required, measurements for spacing and depth are taken. Once poles are installed or verified, the line worker prepares cables for stringing, using lashers, cable blocks, and pulleys. Installation usually starts from one anchor point and moves sequentially across poles. Cable tension must be calculated to prevent sagging or snapping. During this phase, grounding and bonding methods are also applied to protect against lightning or electrical faults. After cable placement, the technician connects junction boxes, terminals, or splice enclosures to integrate the line into the network. Finally, Signal testing ensures the installation is successful and free from interference. Throughout the job, safety checks, communication with the ground crew, and use of aerial lifts or climbing gear are integral. Cleanup and proper documentation conclude the task. This systematic approach ensures the network is built to last and perform reliably. 4. What is your experience with fiber optic cable installation and splicing? Fiber optic cable installation has become a core responsibility for modern telecommunications line workers due to the growing demand for high-speed internet and data transmission. Experience in this area means being proficient in both handling the delicate fibers and ensuring signal integrity. Installation begins with properly pulling or placing fiber cables along poles or inside conduits, ensuring that bend radius and pull tension limitations are not exceeded. Once the fiber is laid, the next step is splicing, either mechanical or fusion. Fusion splicing requires precision equipment that aligns the fiber ends and uses heat to weld them together, ensuring minimal signal loss. Cleanliness is crucial. Even microscopic dust can disrupt light transmission. After splicing, the fiber must be protected using splice trays, enclosures, or domes. OTD are optical time domain reflectometer. Testing is used to verify the quality of splices and identify faults or losses in the cable. A line worker with solid fiber optic experience understands how to handle color codes, buffer tubes, and connectors, as well as safely manage active fiber lines. Familiarity with standards from organizations like ANSI, TIAEIA, or ITU also showcases professionalism. Fiber optics demand accuracy, patience, and care, making it a valued skill in the telecommunications field. 5. How do you handle emergency repairs during severe weather conditions? Emergency repairs during severe weather are one of the most challenging aspects of a telecommunications lineworker's job. When storms, heavy winds, ice, or flooding strike, network outages often occur due to damaged lines, poles, or equipment. Line workers must be ready to respond rapidly to restore service while prioritizing safety. The first step in an emergency call-out is assessing the situation, determining if the area is safe to enter. Downed power lines, debris, or unstable structures must be managed before work begins. Crews work in shifts, often under time pressure and poor visibility, so clear communication and coordination are critical. Using bucket trucks, portable generators, emergency lighting, and insulated tools, repairs are performed to restore connectivity temporarily or permanently. Technicians might need to splice cables, reattach lines, or reroute traffic through alternate paths. Keeping proper PPE and staying updated on emergency protocols ensures survival and efficiency. Experience teaches how to stay calm, prioritize tasks, and adapt methods to harsh conditions. Emergency work demands resilience, technical expertise, and a service-first mindset, as communities rely on these efforts for communication, safety, and recovery during crises. 6. What tools and equipment are essential for a lineworker's daily tasks? A telecommunications lineworker uses a broad range of tools and equipment tailored to installation, repair, and maintenance tasks. Essential hand tools include cable cutters, pliers, wire strippers, and crimping tools. For splicing, precision tools like cleavers and fusion splicers are critical, especially when dealing with fiber optics. A multimeter or tone generator is used to trace and test signal paths. OTDRs help analyze fiber signal strength. Pole climbing gear, safety harnesses, and fall arrest systems are necessary for aerial work, while manhole hooks and confined space entry kits are used underground. Cable lashers, aerial lifts, bucket trucks, and cable pullers help manage large installations. A tool belt keeps frequently used items within reach. Digital tablets or devices for accessing work orders, maps, and updates are increasingly part of modern kits. For protection, line workers wear hard hats, gloves, safety glasses, and steel-toed boots. Depending on the job, specialized items like grounding testers, rope blocks, and weatherproof enclosures may be required. Familiarity and care with these tools increase productivity and reduce errors. The right equipment allows for precision, safety, and speed in completing daily work while ensuring that installations and repairs meet industry standards. 7. How do you stay updated with industry standards and new technologies in telecommunications? Staying current in the telecommunications field is critical, especially for line workers working with evolving technologies like fiber optics, 5G infrastructure, and smart grids. One of the main ways to stay informed is by attending regular training sessions or certification programs offered by organizations like BICSI, FOA, or manufacturer-led seminars. Many employers also provide workshops and hands-on updates for equipment. Subscribing to trade magazines, technical bulletins, or online platforms helps line workers track new standards, tools, or methods. Joining industry forums or union groups creates networking opportunities where practical insights are shared. Some workers use video tutorials or attend webinars for on-demand learning. Keeping up with ANSI, TIAEIA, and OSHA revisions ensures compliance and safety. As manufacturers release updated devices or installation protocols, reading manuals and attending demos improves skill sets. Technology is always advancing, and being adaptable is key. Employers value workers who take initiative, learn continuously, and bring modern solutions to technical challenges. Ultimately, professional growth helps the entire team work safer, faster, and smarter on the job site. 8. Can you explain the difference between coaxial cable and fiber optic cable, and when you would use each? Telecommunications line workers must understand different cabling types to install and repair systems properly. Coaxial cable and fiber optic cable are two common mediums used to transmit signals, but they serve different purposes based on performance, distance, and cost. Coaxial cable has a copper core surrounded by insulation and shielding. It is used for traditional cable television, some broadband internet, and short-distance data transfers. It's durable, easier to install, and less sensitive to physical stress, making it suitable for moderate-speed residential or commercial service. However, coaxial has higher signal loss over long distances and limited bandwidth compared to fiber. Fiber optic cable, in contrast, uses strands of glass or plastic to transmit data using light. This allows for much higher data speeds, lower signal loss, and resistance to electromagnetic interference. Fiber is ideal for long-distance and high-demand applications like backbone networks, 5G connections, and enterprise-level internet. Its installation requires more precision and care, particularly during splicing and termination. A skilled line worker understands where each cable fits: coax for cost-effective local service, and fiber for high-speed, modern infrastructure. Recognizing their physical traits, usage scenarios, and limitations ensures proper system design and long-term reliability. 9. How do you troubleshoot a signal loss in a telecom line? Troubleshooting signal loss in a telecom line requires a systematic approach to isolate the issue and restore service efficiently. First, a line worker must gather information, whether the failure is total, intermittent, or affecting only specific services. Visual inspection of aerial or underground lines is the next step, checking for physical damage such as cuts, bends, or corrosion. If fiber optics are involved, an OTDR is used to detect breaks, splice losses, or connector issues. For coaxial or copper lines, a multimeter or tone generator helps identify continuity problems, shorts, or grounding faults. Testing at various points along the line, such as junction boxes, terminals, or network interface units, helps narrow the problem area. Environmental factors like water ingress, animal damage, or aging hardware are also common causes. Once the source is located, the damaged section is repaired, replaced, or cleaned. Signal tests are then repeated to confirm proper transmission levels. It's important to document the fault, repair action, and result for future reference. Good troubleshooters work methodically, remain calm, and use their experience with cable types and network layouts to find and fix issues quickly, minimizing downtime and service impact. 10. What qualities do you believe are most important for a successful telecommunications line worker? Being a successful telecommunications line worker goes beyond technical skills. It requires a mix of physical ability, safety awareness, and personal discipline. First, reliability is key. Employers and clients expect line workers to show up on time, work consistently, and complete tasks with minimal supervision. Safety consciousness is equally vital. The environments they work in are high risk, so following procedures and looking out for others is non-negotiable. Physical fitness helps with climbing, lifting, and working in tough weather or terrain. Problem-solving ability is essential when diagnosing network issues or adapting to changes in the field. Communication skills support teamwork and help relay information accurately to supervisors or coworkers. Attention to detail ensures that cable installations, terminations, or splices are done right the first time. Adaptability is another crucial trait, especially with technology evolving rapidly. Line workers must be willing to learn new tools, standards, or techniques. Finally, a strong work ethic and customer focus help maintain a positive reputation, as clients rely on timely and efficient service. The best line workers combine strength, knowledge, care, and professionalism in every task they perform. These 10 questions and answers provide a solid foundation for anyone preparing to enter or grow in the role of a telecommunications line worker. Mastering these topics ensures you not only meet technical expectations but also demonstrate professionalism, safety, and adaptability, key qualities in the ever-evolving telecom industry.